Right, so we're going to have a look at all of the organic reactions for grade 12 in organic chemistry. Now this is summarized according to homologous series. So we're going to look at alkanes first. And the first thing I want to focus on here is the reaction where it says alkanes go through oxidation and combustion. Now I'm not going to say much about it, but this is now where alkanes react with oxygen and combustion occurs, for example, with fuels. Then we're going to move on to substitution. The next one there is substitution. This is where an alkane forms a haloalkane. The reaction conditions include that we either need heat or UV light, which is sunlight. And then this is also known as halogenation. So let's just look at the structural formula. If you take an alkane, we have an alkane there, and we add bromine. Now remember, bromine is a diatomic molecule, so 2 bromines. In the presence of UV or sunlight or heat, we see that the bromine, one of them, is going to attach to the original alkane, and then that hydrogen is going to be substituted. So the hydrogen then that is released combines with the remaining bromine, and our other product that forms here is hydrogen bromide. Then the last reaction that alkanes can go through, elimination. Elimination is where we see an alkane forms an alkene and another alkane. So it's basically just splitting it up into smaller parts. It's also known as cracking. So for cracking to occur, we need high heat and high pressure. Now sometimes just know that alkanes, when they go through cracking, they can also form an alkane and hydrogen or an alkene and hydrogen, depending on how many carbons you have. But normally it will be an alkene and an alkane forming. So if we look at a typical reaction for elimination, specifically cracking, we see that we start off with an alkane, and then under high heat, high pressure, we see the formation of an alkene and an alkane there. We have 2 types of cracking. The one is thermal cracking. That's where we have high temperature, high pressure. And the other type is called catalytic cracking. This is where we have a catalyst like platinum and a relatively high temperature. So it's not really that high. 800 degrees Celsius sounds high, but it's really not. So that's the other type of cracking we get. Then let's move on to the reactions of alkenes. So for the alkenes, what's very straightforward here is that they only go through addition reactions. There are 4 addition reactions that we're going to look at, and they've been summarized here. The first addition reaction is called halogenation. So this is where we take an alkene and then we add to it a halogen like bromide, Br2. And then it's going to lead to the formation of a haloalkane. This is a spontaneous reaction, so we don't need any specific conditions for this to happen. The second type of addition reaction that we have here is called hydrogenation. Hydrogenation does not happen spontaneously, but only in the presence of a catalyst. So if you have an alkene and you add H2, in the presence of one of those catalysts listed there, an alkane will form. The third type of addition reaction that can occur is called hydrohalogenation. Now this is where we take an alkene and we add something like hydrogen bromide, hydrogen iodide, or one of the halogens attached to hydrogen. Just very important condition here is that it must be an unreactive solvent, therefore no water. Very important. This is going to lead to the formation of a haloalkane. So basically we see that both the hydrogen and the bromide attaches itself to the alkene. Important here also to remember Markovnikov's rule, which dictates to us where the bromide or the halogen will attach and where the hydrogen will attach. The hydrogen is going to attach itself to the carbon that has the most hydrogen on it already. And then the bromide will attach to the other carbon. That's Markovnikov's rule, and that applies to hydrohalogenation as well as the next addition reaction, which is hydration. So if you have an alkene and you add H2O, in the presence of an acid that's going to act as a catalyst, H2SO4 or H3PO4, sulfuric acid or phosphoric acid, we see the addition of the hydroxide group as well as a hydrogen to the alkene, and this leads to the formation of an alcohol. Once again, where will the hydroxide group attach itself? Markovnikov's rule applies. The carbon that has the most hydrogens attached to it will get the next hydrogen, and then the OH will itself attach to the carbon that has the least hydrogens here. So Markovnikov's rule applies to both type of addition reactions that we're looking at here, hydrohalogenation as well as hydration. Then we move on to the haloalkanes. The haloalkanes can go through two types of reactions. The first one is elimination, and specifically it's called dehydrohalogenation. So dehydrohalogenation is where a haloalkane, in the presence of heat and a concentrated strong base, will form an alkene. So if we look at a structural formula, we see that we have a haloalkane there with bromine attached to it, and then this concentrated strong base is suspended in ethanol, and in the presence of heat and this specific strong base, we see the formation of that double bond. Now the double bond will follow Zeitzev's rule, which says that the hydrogen will be removed from the carbon with the least hydrogens. So if you have a look at that molecule as an example, we see that the carbon that has one hydrogen attached to it and the bromine is removed from it. Then we have to decide which carbon is going to lose the other hydrogen. And the carbon to its left has 2 hydrogens on it, the carbon to its right has 3 hydrogens on it. Therefore, the carbon to the left is going to lose its hydrogen, and therefore one of our products will be hydrogen bromide in this example. Then we move on to the last type of reaction for haloalkanes, substitution. This is called hydrolysis. This is where a haloalkane forms an alcohol. We have 2 ways in which this can happen. The one way is if we have the addition of a dilute strong base, so NaOH aqua and mild heat. Just notice, the haloalkanes in elimination, for dehydrohalogenation we used a concentrated strong base, while for substitution hydrolysis a dilute strong base is used. So that's the difference between the two there, plus mild heat. Or another way in which hydrolysis can happen is if we have an excess of water and mild heat. So if we look at these 2 ways, the first way is if we have a haloalkane in the presence of a dilute strong base like NaOH, we see the formation of an alcohol. The OH attaches itself to the molecule, and we see that the bromine is going to be displaced or substituted, and it will attach itself to the sodium. So one of our products here, sodium bromide. The second way, if we have the same molecule in the presence of an excess of water and mild heat, the bromine is going to attach itself to the remaining hydrogen from water, and the OH is going to attach itself where the bromine used to be, and that's why one of our products is now HBr. Remember, water is actually H and OH. So the H from the water is going to attach to the Br, and the OH attaches itself to the original molecule. Then we need to look at alcohols lastly. Alcohols, we have 2 types of reactions that we're going to look at. Elimination in the form of dehydration. So where we have an alcohol in the presence of an acid like H2SO4, sulfuric acid, an alkene will form. We specifically use sulfuric acid because it's a dehydrating agent. So what will happen here is the removal of an OH and then another H. Now the H will be removed according to Zeitzev's rule, which says that we are going to have to go and find the carbon with the least amount of hydrogens on it, and that one will lose a hydrogen. So the carbon to its left has the least amount of hydrogen, and then we see the formation of the double bond between those 2 carbons, and our product here, one of them as a byproduct will be the formation of water. And then we have substitution. So if you have an alcohol, it can become a haloalkane. What happens here is we take an alcohol, we add hydrogen bromide as an example, and the bromine is going to attach itself where the hydroxyl group currently is, and the OH that is displaced attaches itself to the hydrogen, and we see the formation of water as a byproduct. Another reaction that alcohols go through is esterification, which I'm not going to discuss now. It's a separate discussion, but that basically summarizes everything all in one. If you know the content that we've summarized here, you should be able to answer almost any exam question based on this topic.